Okay, for number 6, we're just going to be performing operations on functions which are plus, minus, times, and divide. So f plus g of x is equal to f of x plus g of x. And that is equal to x plus 3 plus x squared minus 9. So take your f of x function, write it down, put a plus sign, then put your g of x function, and then just combine like terms. This is x squared plus x minus 6, and that is it. Then we are going to do g minus h, which is g of x minus h of x. And my g function is x squared minus 9. My my h function is 3x minus 7. And you have to make sure when you do subtraction that you do use parentheses, because if you don't use parentheses, you're not subtracting the entire function. You're just subtracting the first term in the function. And then once you put the parentheses around, you can go ahead and distribute your negative if you can, which we can. And then I'm going to combine like terms, and I get x squared minus 3x minus 2. And that's it. Now let's go ahead and do g of x times h of x. And my g of x function is x squared minus 9. I'm going to multiply it by h of x. Use parentheses for multiplication. Your h of x is 3x minus 7. And then we're going to go ahead and FOIL that out. I get 3x cubed minus 7x squared minus 27x plus 63. And I do not think that there are any like terms that I can combine, so we're just going to leave that as is. Now let's go ahead and figure out what f of x over g of x looks like. And f of x is x plus 3, so that goes on top. And then g of x is x squared minus 9, and that goes on the bottom. And then we need to factor our x squared minus 9 into the difference of squares, and that becomes x plus 3x minus 3. And I get to cancel this set of factors out, because x divided by x plus 3 divided by x plus 3 is technically 1. Anything divided by itself is 1. And you get 1 over x minus 3 as your final answer there. And you actually don't need those parentheses. You can just write x minus 3. And now we'll go ahead and do we will do f of negative 4 plus g of negative 4. And f of negative 4 is negative 4 plus 3. And g of negative 4 is negative 4 squared minus 9. And then negative 4 plus 3 is negative 1. Then we have plus 16 minus 9. And then you get 16 minus 10, which is 6. And then finally we have f of 3 divided by g of 3. And my f function is going to be 3 plus 3. And my g function is 3 squared minus 9. I get 6 over 0, and that is undefined. Okay, let's go ahead and look at number 7. And number 7, not only do you have to perform the operation, but you are going to have to find the domain. And the domain of a function that has been added or subtracted, multiplied, or divided is just the intersection of the two individual domains. However, if you do divide, then whatever is in your denominator of your new function, you have to set that equal to 0. Let's go ahead and find f plus g of x. So that is going to be f of x plus g of x. And my f of x function is 2x minus 7. And I'm just going to add that to my g of x function, which is the square root of 3x plus 12. And that's it. You can't simplify that any more than that. There are no like terms to combine. So that's the first part of your answer. And then we need to find the domain. And the domain is the intersection of the domains of the original function. The domain of f of x, I'll just put the domain, like D for domain, and then f of x is going to be all real numbers. And the domain of g of x needs to be found by taking your 3x plus 12 and setting it greater than or equal to 0. Because if you have a radicand, you under an even root, you have to set it greater than or equal to 0. So we have 3x is greater than or equal to negative 12, and x is greater than or equal to negative 4. And that would look like this. Here's your number line, negative 4, including it up to infinity. So the overlap or the intersection of the two domains of each one of these functions is from negative 4 to infinity, including negative 4. Okay, so let's go ahead and do f divided by g, which is f of x over g of x with a fraction bar. And my f of x function is 2x minus 7. My g of x function, I don't know why I just wrote that, but my g of x function is the square root of 3x plus 12. And that's as simplified as it can get. And we are going to use the domain that we found in the A part of the problem. The domain is, once again, the intersection of the two domains, except for whatever makes g of x equal to 0. So we're starting with our intersecting domain that goes from negative 4 to infinity. And let's go ahead and figure out what makes g of x equal to 0. And that would be taking this denominator and setting it equal to 0. And so I'm just going to take the radicand out and set that equal to 0. I get 3x is equal to negative 12 and x is equal to negative 4. But that's what x can't equal because it makes a 0 calculate out right here. And the square root of 0 would be 0, so that would just fail. So we are going to take negative 4 out of the domain and remove it out of that intersecting domain, and then that is the domain of f divided by g. It's going to go from negative 4 up to infinity, not including the negative 4. And let's finally do g of x over f of x, which is equal to square root of 3x plus 12 over 2x minus 7. That is simplified as much as it can be. And our overlapping domain, once again, is from negative 4 to infinity. And we need to take away whatever makes our denominator equal to 0. So let's figure out what makes f of x equal to 0. And f of x is 2x minus 7. Set it equal to 0. Solve it. 2x is equal to 7. X is equal to 7 over 2, or 3.5. And that's what x technically can't equal. So we're going to take that out of the domain. So at 3.5 or 7 halves, I'm going to go ahead and remove that out of my intersecting domain or my overlapping domain, and I'll just put a little hole there. And then writing that interval style, we go from -4 up to 7 halves, union with 7 halves to infinity.